Students, let us talk about the torque acting on the dipole. Suppose if a dipole is placed in uniform electric field intensity E, here it is the E, I am placing electron field, and the field is uniform here. So whenever a dipole is placed in electric field, the positive charge experiences the force along the direction of the field intensity like this, and the negative charge experiencing the force opposite to the field intensity. So at the same instant, the dipole experiences two anti-parallel forces, right? So the positive charge is trying to move along the field direction, and the negative charge is trying to move along opposite to the field intensity, right? So here I am taking a small right angle triangle to find the perpendicular distance. Okay, so theta is here. Theta is the angle made by the length of the dipole with the field intensity. So let it be this, the distance is x. So as the length is the 2l, so sine theta is equals to x by 2l, and from this x is equal to 2l sine theta. So torque tau is equal to r perpendicular into f. Here into is nothing but the cross multiplication. So 2l sine theta into f is equals to QE. So the length of the dipole 2l into charge is nothing but the dipole moment P into E sine theta, that is equals to tau. So the same can be written as, in terms of the vector notation, tau bar is equals to P bar cross E bar. This is the important relation between the torque acting on the dipole and the field intensity. It is also known as a restoring torque. So the direction of the torque is perpendicular to the plane of the dipole moment and the field intensity, right? So since suppose if I am considering the mass of the charged particle also, so it is rotating about its center. It's rotating about its center. So if theta is very small, I can rewrite this expression as, let us say equation 1. I can rewrite, if theta is small, very small we can say, then I can say tau is equals to PE theta. Tau is equals to PE theta, right? So here from the definition of the torque in rotational mechanics, I can write the same tau as I into alpha, that is equals to P into theta. What is I into alpha? So where I is the moment of inertia and alpha is the angular acceleration. Since here I am taking this one as a restoring torque, I should take minus. So that minus indicates that angular acceleration is acting opposite to the angular displacement, right? So from this I can say alpha is equals to minus PE by I into theta, which implies, so alpha is equal to some constant into theta, which implies alpha is directly proportional to theta with minus. So be careful, here I am taking the alpha and proportionality both are equal. So why ఎందుకు alpha alpha minus theta రాసారేంటి అనుకోదు. This is the angular acceleration, this is the proportionality meaning. So alpha is directly proportional to minus theta, right? So which implies that torque is exhibiting that angular SHM. The torque is experiencing the angular SHM. So for angular SHM we can find the time period of the oscillation. So for the expression, the time period of angular SHM T is equals to 2 pi into root over theta by alpha, right? So this is the equation 3, equation 2 we can say, equation 3. Equation 3, right? So from the equation 3 we can say theta by alpha is nothing but I by PE. This implies 2 pi into root over I by PE. Maybe you're listening my kids, వాడు ఏడుస్తున్నది కూడా మీకు వినిపిస్తుందేమో. Please do concentrate on the class as I am, right? So from this we can find the angular frequency of the dipole itself. So we know that T is equals to 2 pi by omega, which is equals to 2 pi into root over I by Pe. From this a very simple mathematics, right? So from this angular frequency F is equals to 2 pi F, if I am saying, so that is omega by 2 pi, it means 1 by T. This is nothing but root over Pe by I. This is the I is nothing but the center of mass, moment of inertia, right? So for a particle, for a two particle system having masses m and about its axis it is rotating, if I am saying, and the length of the dipole is 2l, so this same thing F is equals to root over Pe by 2ml square. This is for to find the value of the angular frequency of the rotation, right? This is very useful to solve the numericals, some of the numericals, right? Thank you.